One of the most common customer complaints you'll get in a workshop is an engine that cranks slowly or only makes a clicking sound when the starter is activated. Often it's just a flat battery, but there are also quite a few other faults that can cause this. Hi, I'm Haddo. In this training video, I'll show you how to test the starting system and confidently diagnose faults. I've also made a starter circuit test sheet with step-by-step instructions that you can print off to use in the workshop. You'll find a link to this document on the home page for this module. I'll use this test sheet as a reference, so it'd be great if you had a copy before we proceed. All right, let's kick off by having a look at what makes up the starting system. We have a battery, a starter motor, the electrical wiring, electrical switching, and of course the engine itself. Any one of these areas can and do cause problems. We'll begin by unpacking each one in a bit more detail. To test the starting system, you'll need a digital voltmeter and an induction amp clamp. Let's look at the check sheet. I'll use this for my testing and record my results. Section 1. Confirming the fault. Try and start the engine and tick the relevant box. Section 2. Battery checks. Perform a visual inspection of the battery and terminals. You must disable the engine from starting. On this vehicle, I'll just remove the EFI fuse. I like to use a dedicated battery tester, but for the purpose of this video, I'll perform a cranking test. Here I've got 12.47 volts with no load. I'm going to crank the engine for a maximum of 15 seconds, but I'll stop if it drops below 9.5 volts. That dropped to 10.35 volts. This battery passes, so I can proceed to section 3. You will see that each test is numbered and the numbers correspond to the diagram on page 4. For example, if you are conducting test number 4, this is where you place the voltmeter leads. Remember, when conducting a starter voltage drop test, the starter must be operating for each test. Here's a tip for you. Always measure voltage drop a few times. I found if the reading is consistent, it will be resistance in the leads. If the reading keeps changing, it will be a bad contact or switch. Okay, test number 1, earth and battery positive. Crank the engine and observe the battery voltage. Note you must have the voltmeter on the battery posts and not the terminals. Here's a tip. You only want to crank long enough to get each result. You can also combine section 7 with this test if you like, so you don't flatten the battery. Crank please. I'll just record each test result as I go. Test 2, earth and positive on starter motor. I'll look at the diagram to ensure I know exactly where to place my meter. Crank please. Test 3, positive of battery and positive on starter motor. Crank please. Test 4, positive of starter motor and starter motor positive of solenoid. Full starter current is switched across the solenoid, so it's common to see some voltage drop here. Crank. Test 5, earth of battery and metal case of starter motor. Crank. Test 6, battery positive and key start terminal of starter motor ignition switch to the solenoid. That's this small wire from the ignition switch. Crank. It's also common to get some voltage drop here, particularly in older vehicles that don't run a start relay. See, I got 0.7 of a volt. In terms of engine cranking speed, you get to know if everything's okay just based on the sound. I'd say this one sounded quite good. Okay, I've got all the results up here. Let's go through each one and discuss. I thought this engine's cranking speed was okay, but we'll verify that with the results. Battery checks. In this case, the terminals looked okay. Section 3, starter voltage drop test. As you know, we did supply voltage and voltage drop tests. A key point to remember is the voltage I see here at the battery, I should also see here at the starter with no drop. As a general rule, maximum voltage drop on the positive side for a 12 volt system is 0.5 of a volt overall, or 0.2 at any one connection. On the earth side, 0.2 of a volt overall. So let's see what our results were. I'll give you a few tips about what to look for as we go, and I'll conduct some pinpoint tests where necessary. Test 1, earth and battery positive. This is like our pressure storage bank. We want this one high. I had 10.4 volts, so that's within specifications. Most specifications say a minimum of 9.5 volts while cranking, but there are vehicles where the ECM will not switch on unless they receive 10 volts. Test 2, earth and positive on the starter. This one checked how much voltage I was getting into the starter solenoid. In theory, it should be the same result as in test 1. Test 3, positive of battery and positive of the starter motor. That was a voltage drop test. Remember that voltage is electrical pressure. On test 3, I can see that I've lost just under 0.5 of a volt. That's less pressure to do the work. Not good. Now we need to pinpoint where the voltage drop is. If I put this lead on absolute zero or battery negative and this lead on a pressure of 12, the meter will show the difference in pressure, so it'll show 12 volts. However, if I put this lead on 12 volts and this lead on 10 volts, it reads a difference in pressure between the 2 points. Now let's check for voltage drop with this battery terminal and post. Remember, you must have the current flowing, so I'll need to crank the engine. I should have the same voltage here as I do here, so I should get 0 volts drop. Crank please. Yes, all good. If high, obviously I'd have to clean the terminals. On test 4, positive of starter solenoid and positive of starter motor. It's common to get some voltage drop here. Have a look at this one I've got pulled apart. This is typical of what you see. I always put a solenoid kit in, or at least replace these terminals and clean this disc. Here's a tip. If you have excess voltage drop here, pay attention to the voltage drop test results through the switching circuit. I'll come to that in a minute. Test 5, earth of battery and metal case of the starter motor. As it's on the earth side, I should have a maximum of 0.2 of a volt overall. Test 6, battery positive terminal and key start terminal on starter motor. It's common to get a high voltage drop here, particularly in older vehicles with no relay. Current flow through here creates a magnetic field in the solenoid pull-in winding. Voltage drop reduces current, so less current equals less magnetic field and slower solenoid operation. This results in more time for arcing of the high current at the solenoid contacts and a high reading on test 4. Older vehicles without a start relay tend to give more problems. Most problems are caused by the length of wiring or arcing of the ignition switch and park neutral switches over the years, so fitting a relay will fix the problem. With test 7 for current draw, the size and design of the engine will determine how much current the starter will draw. Rarely will you see a specification. It's great if you've tested similar vehicles and recorded results. Generally, it's about 40 to 50 amps per litre of engine capacity for a petrol engine, but this can vary. Okay, let's look at the diagnostic table. This one tested okay, all within specifications. Here's one I tested last week. This test result would fall under example E and more specific at test 4. I fitted a new solenoid kit and performed a retest to confirm the fix. It was an easy repair. With experience, you may reduce the number of tests. For example, if you have 10 volts at the battery and you have 9.5 volts at the starter solenoid, then mathematically, I know I've dropped 0.5 a volt in the positive lead. Some people underestimate voltage drop. Let's do some basic calculations to show the importance. Let's say we test the starter motor. It has a supply voltage of 10 volts and is pulling 200 amps. Therefore, the starter would have 2000 watts of power, or 2 kilowatts. What if we had a voltage drop of 0.5 to the starter? That's within specifications, but less pressure will push less amps. So now we only have a current draw of 180 amps. Do the calculations and you'll see you now only have a 1.7 kilowatt starter motor. That's why it'll crank slow. It's lost 300 watts of power. It's great if you can print and laminate this sheet. It will help remind you where your test leads go and you can record your results. Accurate diagnosis is key. I'm Haddo. Keep training and thanks for watching.